Oh, hi, I didn't see you there. My name is Will, and today we will be looking at the amazing golden ratio. My friend Juan will also help us explore the incredible and golden things about this ratio. Oh, that's not Juan. That's Ander. Say hi, Ander.
Hey. So let's start with the idea of what the golden ratio is. Will, would you like to tell us?
Yeah, okay. Throughout history, the ratio for length to width of rectangles of 1.618033988749894844820. Did you get that?
Yeah, I got that. I wrote it down and everything.
Oh, okay. Has been considered the most pleasing to the eye.
To the eye?
Yeah, to our eye.
To our eye?
Yeah.
No.
This ratio was named the golden ratio by the Greeks. In the world of mathematics, the numeric value of pi, named for the Greek sculptor Phidias.
Wait, Will, I still don't get it. Would you mind explaining it to me further?
Okay, man. Suppose that you have a piece of rope and you cut it in some place so that you now have two pieces of rope.
Two pieces of rope, yes.
So if you cut in the middle, then the two pieces are equal, so their lengths are in a 1-to-1 ratio.
Alright, yeah.
If you cut the rope 1/3 of the way down from one end, then the bigger piece will be twice as long as the smaller piece, so their lengths are in a 2-to-1 ratio. Did you get that?
Yeah, I got
Did
that.
you write it down?
Yeah, I wrote it down and everything. You guys should be writing this down.
Write it down now.
Yeah.
In theory, it's possible to cut the rope so that the ratio of the larger piece to the smaller piece is the same ratio as the original uncut rope length to the biggest piece. This special ratio is defined as the golden ratio. There are lots of equivalent ways of defining it, but that's the most formal way.
Wait, I get it now. Thank you, Will.
Good, man. But Juan, what I don't get is, how do we construct the golden ratio geometrically?
Well, Dan Brown popularized the golden ratio in his book, Angels and Demons. He talks about everything having some association to the golden ratio. To calculate the golden number, it is good to know Fibonacci sequence. The sequence is quite simple. You start off with 1, 1, and the second number is 1. Now you add the previous two numbers, so 1 plus 1, which is equal to 2. Add the previous two numbers, 2 plus 1, is equal to 3. Notice the sequence goes on like this, so you'll have 1, 1, 2, 3, 5, 8, 13.
Ha! Run out of fingers.
Yeah.
Maybe we should do this.
Now calculate the golden ratio. You calculate the last number you have, 13, and divide it by 8, which is 1.625. The further you go along the Fibonacci sequence, the closer you will get to the golden number.
Wow, that's golden.
Isn't it? I know, right? Wait, so how does the golden ratio and its related concepts appear in architecture?
Now that's a good question.
Is it?
The Ahem's Papyrus of Egypt gives an account of the building of the Great Pyramid of Giza in 4700 BC. That's before Christ, if you didn't know.
Oh,
with
yeah.
proportions according to a sacred ratio. Also, even from the time of the Greeks, a rectangle whose sides are in the golden proportion has been known since it occurs naturally in some of the proportions of the 5 Platonic.
Platonic?
Yeah.
That's a big word.
This rectangle is supposed to appear in many of the proportions of that famous ancient Greek temple in the Acropolis. And finally, the medieval builders of churches and cathedrals approached the design of their building in much the same way as the Greeks. They tried to connect geometry and art inside and out. Their buildings were intricate construction based on the golden section.
Oh, wow. So now we know it all.
Wait, no. I don't get what are the applications of the golden ratio and its related concepts in architecture? Please tell me, hurry up.
Oh, jeez. Thanks for reminding me of that one. Well, aesthetics, painting, book design, industrial design, music and nature.
But why is this all so important?
The golden rectangle has been said to be one of the most visually satisfying in geometric forms. We can find many examples in art masterpieces such as edifices of ancient Greece.
Ancient
It's,
Greek.
yeah. It's very important. It's even important in Mona Lisa. If we can draw a rectangle whose base extends from the woman's right wrist to the left elbow and extend the rectangle vertically until it reaches the top of her head, then we will have a golden rectangle.
That's the golden rectangle.
Also, if we draw squares inside the golden rectangle, we will discover that the edges of these new squares come to all the important focal points of a woman: her chin, her eye, her nose, and her upturned corner of her mysterious mouth.
Yeah, it is mysterious.
It's believed that Leonardo da Vinci, as a mathematician, tried to incorporate the mathematics into art. This painting seems to be made purposely line up with the golden rectangle. I hope that helped.
Wow, thanks man. You are the best.
I know I am. So are you, man. Well, that's it for now. See you next time.
I hope you learnt a lot today.
Yeah, and don't forget to write that down when you watch it again. Bye.
Bye. Bye.